So example number 7 is a what we call a composite function. It's a combination of two functions. So sometimes there's a sinusogenous behavior. In other words, there's some sort of periodic behavior that repeats, but it doesn't repeat exactly the same every time. So you can combine a circular function like sine or cosine with another function to kind of get this periodic behavior, but also it takes on the property of the other function. So let me show you what I mean by this. In Desmos, do me a favor, graph y equals x. And let's just set our parameters in Desmos. Let's just go from like -10. So click on this little wrench here. Go from -10 to 10. In the x-axis, go from -10 to 10 in the y-axis. And you can scroll your mouse too. It doesn't have to be precise. But I just wanted you guys to see, like you can zoom in and out using the mouse pad and stuff. But anyways, we know what that is, right? That's a linear function, the slope of 1, y-intercept is 0, right? Now, what is the second part of this function? Well, it's cosine of pi over 3 times x. So now type in y equals cosine, what was it? Cosine of pi. So now to get pi on Desmos, you just type in pi. To make a fraction, you hit the slash like a division symbol. And what was that? Over 3? Yeah. Over 3, whoops, somehow, times x. So those are the two functions. Okay, and I'll give you guys a second to get those plugged in. Now, if I combine them, if I add them up, watch what happens. So if I type in, so go ahead, click on these circles here, and it'll turn them off. They're still there. But watch what happens when I combine them. If I say y equals, and you guys type this too, y equals plus cosine of pi divided by 3 times x, you kind of get the combo of the two, right? You've got this periodic behavior, a pattern that repeats itself, but the y values increase over time. And if you scroll out, it looks like this. Can you guys think of something in the real world that kind of looks like that?
Piece of hair.
A piece of hair? I'm talking about data. How about the stock market? Right? Stock market goes up, comes down, goes up, comes down, goes up, comes down. But anyways, in the real world, what they do is they take these equations and they model the equation to the data. So I'm currently doing a thing with my Algebra 2 kids where we're actually collecting stock market values over a 5-year period, and a lot of times the pattern looks like this. And so we could tweak this equation however we wanted to. In other words, if I wanted to increase the steepness of this, if I put a 2 in front of the x, watch what happens. Steeper. If I change that to 0.5, not as steep. So on these problems, I might give you 1 or 2 of these, but if you have a composite function, at this point, just graph it in Desmos. And really what I want you to do is think about graph the first function, graph the second function, then graph the composite function, so you could see how it's a